for 3-3 day 2, we want to start off with a little bit of a warm up, kind of recapping what we did yesterday. So go ahead and pause the video, try these two out, and then we will go over it from there. All right, so now that you've had some time to take a look at these, this is what we should have ended up coming up with. So for number 1, the 3 is a vertical stretch, the +1 is left 1, and the +2 is up 2. So we should have moved the points left 1 up 2. From there, the vertical stretch, remember, you take your original function and you multiply your y value by 3. So that's why it ends up being what it is. Okay, so that second point was at 2, and so if it's at 2 and then you multiply 2 times 3, you get that 6. Okay, so that's why this one is 0. So after you move it, you don't move it any further as well, because it would have stayed right where it was at. So that's why that one doesn't move. For number 2, it was a reflection. So already we should know it should look something like this, but it also was moved right 4. So this one you might have had to do in 2 parts instead of doing it all at once, but that would have been your final result. So let's take a look at these things one more time and just organize it in this chart. Okay, so first off, the first thing that you notice is that you have an A value, right? Remember, A value, if it's greater than 1, that means that it stretches it. So it's going to get bigger. Whereas when it's between 0 and 1, aka this one pretty much is, if it's a fraction, obviously it has to be a fraction less than 1, but typically the fraction is what gets it. That's where you're going to compress it, right? And then compresses. And then if it's negative, that's where you get the reflection, right? It reflects, and then it's always going to be your x-axis. So this is kind of like that flipping process, right? So the next thing that we come up to is the green, right? That's our h value. Remember, this is always the opposite, right? So you always think about it just like kind of like point slope. Okay. And that means that if h is positive, then the graph is going to move left. And if h is negative, it's going to move right. Okay, so it is the opposite sign of what you think it is. Now, k, on the other hand, because it's not in parentheses, it ends up being the same. Okay, and that's because normally this k value is with your y over here, which is when you do the opposite. In this case, it's away from the y, so you're not doing the opposite. You're going to end up doing the same, okay, doing the normal. Okay, so that means if k is positive, then the graph is going to move up. If k is negative, then the graph is going to move down. Okay, so this is a good resource for you to keep using as we move forward if you feel like you need it. So we're just going to do a bunch of different examples, focusing on linear transformations. If we don't make it through all of them, feel free to look through the completed notes because they'll all be on OneNote. Okay, so the first thing that this asks us to do is graph the line. Okay, so they give us a function f of x and we want to graph it. This is in slope-intercept form. So we would start up 5 and then move our slope, which is negative 2/3. So down 2 over 3, down 2 over 3. And I'm just going to do 2 in both directions, just so that it's easier for my graph to look nice. Notice how I did a really good job going through those lines. Okay, so we want to identify the y-intercept. Well, the y-intercept is right here. Okay, so that y-intercept of 0, 5 is what we're going to use to help move us to graph g of x. Okay, so g of x is transformed by this. Okay, f of x plus 3 minus 6. So the plus 3 means left 3, and the minus 6 means down 6, right? So I'm going to take that specific point and I'm going to move left 3 and down 6, which is right here. Now it said nothing about slope, so we're going to go ahead and graph that equation now. So my slope is the same. Down 2, right 3, down 2, right 3, up 2, left 3, up 2, left 3. And there is my next equation, my next graph. Okay, so now that we've graphed it, we need to write that equation, and that equation would be y equals, our slope stayed, oh, let me try this again. We don't want y equals, we want g of x. So g of x equals, our slope stayed the same, which was negative 2/3. And now our y-intercept has changed. Don't just use the point that we moved, because that's no longer a y-intercept, right? Now our y-intercept is here, which means that it would be at a negative 3. So this is the process we're going to do for most of the day today. So let's take a look at another example. Okay, we're going to graph this line. So again, we're going to start at our y-intercept, which is at negative 3, and move our slope, which is 1/2. Up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2. So here's my graph. Again, you can do more or less. It's fine when it comes to points. So again, let's just use our y-intercept to help us move. Okay, you can move any one of those points, but I feel like it's easy to just start there. Okay, so now we're gonna graph g of x if g is 2 times f of x. Now remember, anytime we have that, really you're just multiplying the y values, right, by 2. Okay, so this is a vertical stretch because it's greater than 1 of 2. So if I focus on that point is 0, negative 3. So if I want to stretch it and double it, it would be at 0, negative 6. Okay, so we would move it here. Now the problem is my slope doesn't necessarily stay the same here, right? Because we're stretching it. So if we just move it to there, it would just be moving down 3, right? And that's not what it said to do. It said stretch it, right? So we need to pull it vertically. So let's go ahead and test this point as well, okay? That point is at 2, negative 2. So again, if we multiply our y value, it would be at 2, negative 4. So we would be here. Okay, now technically you do not have to keep going. I always like to have at least 3 points, so I'm going to do this one as well. Okay, so this one is at negative 2, negative 4. So if I want to change this, it would be negative 2 to negative 8. So I would go down 2 more. Okay, oop, I didn't move over enough. Okay, now what you could have done is found the slope between these two, okay, which is the slope of 1, and then gone that route, okay. So basically what's happening here, if you've noticed, maybe you have, maybe, actually, let's do C first, and then we'll look at it, okay. If we're going to write our equation of this, our equation now is different, right? Oh, I did it again. We need to do g of x. So in the habit of writing y equals, right? G of x equals, now I know that my y-intercept has now become negative 6, but now we need to look at our slope. Well, we went up 2 over 2, which means 2 over 2, which is 1. Okay, you don't have to write the 1. You could just write x minus 6. Okay, now, if you notice what's happening here really, and you can still follow this process over here that I did, okay, but what's really happening is when you have that vertical stretch, you're multiplying your slope by that. Okay, so your slope then became 1 because 2 times 1/2 is 1. So you would have just graphed your y-intercept and then moved 1. Okay, so any process that you want to do, totally fine. I prefer this one just to make sure that I'm being consistent and not making some small error. I think it's easier, but that's up to you. So then we have example 5. We're going to go ahead and graph this one. We moved it up 1. And then our slope is down 2 over 1, down 2 over 1, up 2 over 1, up 2 over 1. So here's my line. And again, we're going to focus on this y-intercept to move it. This one is reflected over the x-axis. And this plus 3 means left 3. Okay, now remember, reflection over the x-axis means that you basically just flip where it's at with the y values. So the y values change signs. We're going to go ahead and do this at the same time. So I am going to move it left and then reflect it. Okay, so if we move it left 3, we would be right. So focusing on our y-intercept, 1, 2, 3, and then we would flip it to go to -1. Okay, because it would be at a +1, so we want a -1 for our y. Then we could do the same thing for our next one and move it left 3, which would be here, at a 3 for our y value, which means we go to -3. Okay. Once you have 2 points, you can think about it more as slope, right? So my slope, I moved up 2 over 2, which means that I'm actually just kind of moving up 1 over 1 the whole time. Okay. Or you could do up 2 over 2. That's fine. No big deal. As long as you have this line. Remember, it doesn't actually matter how many points you have as long as you have at least 2. All right. So that would make our y-intercept at 2. So I know g of x, look, I remembered this time, equals our new slope, which was 1, right? X, and then plus 2. Okay. So that's the last example like this. We're going to look at it just a little bit different for our last problem in the notes. So this time you're given 2 lines, and you have to then write the equation. So the equation for f of x in slope-intercept form, we would start it as f of x equals, and we need to find our slope. So we obviously have 1 point to start with. I'm going to find the next point to be right here. So if we do rise over run, we go up 1, 2, 3, and then we move over 1, 2, 3, 4. So that means my slope is 3 over 4x, and my y-intercept is identified here as -2. Now what it's asking in part B is describe how the point that is graphed on f of x, aka our y-intercept right here, okay, was moved to get the point graph on g of x, which is right here. Okay, well, you can think about this a couple different ways, but essentially, I would say it's moved up 2, and then it's moved left 1, 2, 3, 4. Now we want to write an equation in terms of f of x using the transformations. So that means I want g of x equals, and then something to do with f of x. Well, this left 4 means we're going to have a +4 with the h, right, for our h value, because it's always the opposite of what we think. And this up 2 is talking about k. So remember, h is on the inside, k is on the outside. So this would be f of x plus 4 and then plus 2. Okay, and you can always re-look at it after you write it, like, okay, does this make sense? Well, this would tell me left 4. This would tell me up 2, which is what we had here, which means this is right. Okay, so at this point we have a worksheet for homework. Go ahead and check that, or start that. Make sure that you're checking your answers and asking questions on anything that doesn't make sense to you, okay, because this is a very important topic.